Today I will be discussing on hypothesis testing. This is one of the important chapters because it is the important step wherein the actual analysis part takes place, or actual analysis come into consideration while a research study. Here, when we collect the data and go for execution, we use certain statistical models. And while using these statistical models, we have to work within a framework wherein that will provide us the better results. Thus here, when I talk about hypothesis, it is nothing but analysis of the data for the prediction that we have done. Here, hypothesis is in the beginning of the process. Once the literature review is done, we will be working on a hypothesis where we talk with different experts, or we talk with different records and literature by different authors. Then he has to work for a hypothesis and draw out a logical and empirical consequences, so that this hypothesis should be very specific, it should be limited to a piece of research, and so that it can be tested. Thus the role of hypothesis here is to guide the researcher by delimiting the area of research and to keep him in a right track, so that it sharpens his thinking and focuses on a subject area. So the today's topic will be Unit 4. When I talk about hypothesis, we need to understand what is meant by this hypothesis, and then we will come back to testing of hypothesis. Thus, under research, there are various definitions with respect to hypothesis, and it is usually considered as one of the principal instruments in the research. Once sampling design and run for experiments is done, then we go for formulation of the hypothesis. What about the definition of hypothesis here. It is nothing but, it simply talks about certain assumptions, or it is certain proposition of a set of statements. For example, an automobile A is performing well than automobile B, which can be tested by various data. Similarly, students who receive counseling will show greater interest in the creativity rather than students who are. So this is what we call. Thus, sometimes we refer it as occurrence which can be tested. And also the hypothesis test enables us to make the about the population parameter, and maybe not be proved, or maybe not disagree. Hence, the hypothesis very much well known for the researcher. Now, thus we often make decisions with respect to, and we require a huge amount of data through a data collection method. You all have learned primary data, secondary data, after that sample design, research design, sampling design. Once the entire population, we go for decisions such as statistical decisions. If these statistical decisions are considered, then it will be with certain assumptions. Such decisions are called, such decisions where certain assumptions exist are termed as statistical hypothesis. But if we go for certain experimentation, then the experimentation provides a method called as hypothesis testing, where we define the problem, propose the hypothesis, and using some method we either test it and say that it is accepted or rejected. Thus, the ultimate purpose of experimentation is generalization and the variable relationship, so that it can be applied not only within the constrained environment of a researcher, but it can be applied to outside environment as well. Then, what are the characteristics of hypothesis? When I talk about characteristics of hypothesis, the hypothesis must follow certain aspects. Here, hypothesis or statements that a researcher do for any research work or research study, it should be clear and precise. The first is, it should be clear and precise, so that it is very well understood by all the other authors. And proper inferences can be drawn on this basis, and it is reliable. So this is required for proper inferences, and so that it is reliable. Then when I talk about hypothesis, it should be capable of tested. So when is performing well then there are certain run. Hence, those tests can be performed. Hence, when I talk about hypothesis, it can be tested. So, these are the important characteristics of a hypothesis. Then, here, if a swamp of untestable hypothesis, then what happens? He has to make a prior study and understand. Otherwise, if it cannot be tested, then it becomes a mere statement. Hence, the hypothesis is testable if other deductions can be made from which whether the observations can be disapproved or it can be approved. The next characteristic is state of relationship should exist between the variables, and it happens to be a relational hypothesis. So, hypothesis, when we are stating, it happens to be a relational hypothesis. In this case, as I said, automobile A versus automobile B. Then, the relation between the common variables need to be understood. So, those things are taken care in the hypothesis. Hypothesis should have scope, limited scope, and it must be specific. I'll just write it here. It should be it should have a limited scope and specific. Specific scope is required because the testing capabilities comes into picture and the funds available for testing is a main concern here. Hence, prepare or propose a hypothesis such that it is very specific to a particular variable or a data. Then, hypothesis should be stated in far simple terms rather than complex, and there are substantial body of established facts so that it can be judged and accepted most likely by various other organizations or authors or any other institutions. So this is how the hypothesis should be. A hypothesis should be amenable to testing with a reasonable time, so that no doubt it can be tested, but it should be with respect to it. It should not take longer time, because ultimately we need to go on providing the inferences with reliable results. Thus, it should be attached with time. Hypothesis must explain the facts and give rise to the need of explanation. Thus, hypothesis must actually explain what it is supposed to explain, and also provide certain empirical response so that further scope can be attained. So these are the basic characteristics of the hypothesis. To attain or prepare the hypothesis, there are basic concerns we need to consider for testing the hypothesis, and these concepts must be very clear before we take up a chapter of testing of hypothesis. There are two levels like hypothesis testing, type 1 and type 2, that we will be learning in detail, but here I am talking about testing of hypothesis, procedure for hypothesis testing, formulation of hypothesis and testing the same, data analysis and analysis of variance. So in a very brief manner I will be discussing this chapter. Then, basic concepts in the context of testing of hypothesis can be explained in this manner. First is, under the concepts, here you need to understand null hypothesis and alternative hypothesis. Then, the next I'll just list down the concepts so that they are very clear. Level of significance, then the third is decision rule or test of hypothesis. Then type 1 and type 2 errors. Then two-tailed and one-tailed test. This is one of the interesting aspects where we will learn the different tests that can be considered with respect to the hypothesis, and then we will come for procedure of hypothesis testing later on, formulation and then testing. Here when we talk about basic concepts, these concepts are relative to the study, and it depends on the researcher to what extent these concepts needs to be included in their research work. It may be null or alternate hypothesis. It may be the level of significance or the decision rules one is considering. Then type 1 and type 2 errors, or one is going for two-tailed or one-tailed tests. Okay. Here when I talk about null hypothesis and alternate hypothesis, it is with respect to the statistical analysis. The statistical analysis, we often talk about the null and alternate hypothesis. If we compare method A and method B, there is method A and method B. If we compare it, then we are talking about the superiority of the two methods. If we proceed on the assumption that both are equally good, then this assumption is termed as null hypothesis. Both are equally good. Then it is null hypothesis. No variation exists in terms of statistics. Against this, if we think that method A is superior or the method B is inferior, both is possible. Method A is superior or method B is inferior, then we call it as alternate hypothesis. The null hypothesis is usually denoted by capital H0 and the alternate hypothesis is given by capital HA. A is for alternate. Suppose if we want to test this for a population of mean mu and the hypothesized mean is equal to 100, we would say that under null hypothesis, the population mean is equal and it is hypothesized mean is equal to 100. Thus, H0 is to mu is equal to mu H0, which is equal to 100. This is how we state the hypothesized mean, and symbolically that we write. This is called as null hypothesis. Now, if the sample result does not support the null hypothesis, then we should conclude that something else is true, or we conclude here rejecting that it is not a null hypothesis, and hence it is known as alternate hypothesis. In other words, the set of alternatives to the null hypothesis is referred to as alternate hypothesis. So, if we want to accept H0, then we are rejecting HA. If we want to accept HA, then we are rejecting H0. Thus, we may consider the following three possible alternatives here. The three possible alternate hypotheses may include, and it has to be read in this format only. So, alternate hypothesis, it says that HA is to mu is not equal to mu H0. The alternate hypothesis says that the population mean is not equal to 100 and it may be more or less than 100. This is what it says. Then, alternate hypothesis, mu greater than mu H0. The alternate hypothesis in which the population mean is greater than 100. HA is to mu less than mu H0. The alternate hypothesis when the population mean is less than 100. So, this is how we go in for alternate hypothesis. These are the three alternatives that we can get. Alternate hypothesis that we can get. Thus, the null hypothesis and alternate hypothesis are chosen before actually the sample is drawn. And the researcher must avoid the error in deviating from these hypotheses so that the testing for the hypothesized data can be there. Thus, while going for a choice of null hypothesis, the following conditions should be kept in mind. Alternate hypothesis is usually one which he wishes to prove, and the null hypothesis is the one which he wishes to disapprove. Thus, the null hypothesis represents we are rejecting it, and alternate hypothesis represents that there are some possibilities of acceptance of the data. If the rejection of certain hypothesis wherein actually it is true, then it involves certain greater. If there is null, we are accepting the null hypothesis, then there is some difficulty in understanding the data, or there is some risk with data that we are using. Thus, it is because that the probability of rejection when it is true, then the level of confidence becomes very small. Null hypothesis should always be a specific hypothesis, and it should not state any approximate or a certain value. Hence, hypothesis testing when we proceed, if it is based on null hypothesis, keeping the alternate hypothesis in view, then there is one assumption that null hypothesis is true. One can assign the probabilities to different probable samples, and it can be done using the null hypothesis. However, if it is use of null hypothesis, then using the statistical hypothesis, it is quite frequent to happen. So all these points need to be understood when I talk about null hypothesis. Then the next one is level of significance. When I talk about level of significance, this is one of the important aspects for defining the hypothesis. So if we are talking about null or alternate hypothesis, we are talking about with what confidence level are we stating it. Or if I say when method A is superior to method B with a confidence level of 0.5% or 0.05%, then that confidence level tells us about the background information that exists to the data collection or analysis part. Hence, this is a very important context of hypothesis testing, and it is always in some percentage, usually 5%, and it should be chosen with great care while the research data has been there. And the significance level, if it is 5%, then it implies that H is 0, that is null hypothesis will be rejected when the sample results, and less than 0.05 probability offering if H0 is true. In other words, 5% level of significance means researcher is well within the context of the data, and there is only 5% of risk with the data that exists, and only 5% happens to be null hypothesis. Thus, then only when a researcher has to start the study. Then the next is decision rules and testing of hypothesis. Here there are various decision rules that one can go through. Given a hypothesis that is null and alternate hypothesis, the decision has to be done alternate hypothesis. So that is possible. We must decide the number of items that are to be tested and the criterion for acceptance or rejection. That is the reason we go for level of significance. We say that every one item can be defective with a lot of 50. Hence, we can accept that null hypothesis is 1 and acceptance level with respect to that HA can be considered. That is alternate hypothesis can be considered. This sort of base is known as decision rule. Then when we come for type 1 and type 2 error, I will just write down the decision here with respect to type 1 and type 2 error. So these are the basic concepts part of analysis. If there is a decision that needs to be taken where HA is not is false. This decides the type 1 and type 2 error. Not reject H naught. So here also it is O. Alpha error, type 2 error, beta error, corrected decision. In the context of testing of hypothesis, these two are the important types of errors that one needs to understand, because many of the data may fall within this format of decision with respect to null hypothesis. And if we may reject H naught, when it is true, then it is called as type 1 error. If we may accept H naught when the null hypothesis is false, then we call it as type 2 error. Then type 1 error is usually denoted by alpha error, and it is also called as level of significance of the test. Clear? Then if it is type 2 error denoted by beta, then it is when we accept the null hypothesis. When the null hypothesis is false, we call it as type 2 error. Now we understand here that probability of type 1 error is usually determined in advance and is understood much well. Say we fix 5% defective items, then we know that there are 5% chances of being defective over 100. Hence, we can reject H naught when H naught is true. So this is maximum probability of committing type 1 error would be only 0.01. But with a fixed sample size n, we can try to reduce the type 1 error and the probability of committing also type 2 errors. But probability of committing type 2 errors may increase. Thus, both type of errors cannot be reduced simultaneously. Hence, either probability of making one type error can be reduced, the other type of error may increase. If type 1 error involves time and trouble for reworking, then batch of chemicals, then that should have been accepted. Whereas type 2 error is taking a chance that an entire group of chemical compound is poisoned, then in such situation, one should prefer type 1 error to a type 2 error. So it depends on the type of situation that we are applying this type 1 error testing technique or type 2 error testing technique. Hence the testing of hypothesis, there has to be a possible balance that needs to be made between the type 1 error and type 2 error. Is this clear? So this is with respect to the decision that is considered. Then we will be going for the next, that is one-tailed and two-tailed tests. The other aspects here I will just discuss is that with respect to these aspects, if I consider the level of significance, it is usually indicated with some percentage. It implies that always H naught is rejected when the sampling result has less than 0.05% of the probability occurring. Thus, there is 5% of risk by rejecting the null hypothesis. So that becomes the maximum value for rejecting H naught, and it should be done prior advance. Here another example we can take to test the specimens to get the mean value of the yield strength. Then type 1 error is to reject when the fact is true and the mean that steel would be shipped back to the supplier with resulting in a financial loss and penalty to the builder. On the other hand, if type 2 error exists, accepting H naught would be false because the steel is of inadequate strength And if we construct with poor quality, perhaps there will be failure. And thus type 2 error should always be minimized with respect to the engineering situation. So this is what we understand from this decision. And then comes one-tailed and two-tailed tests. I'll just show one-tailed test so that it will be much clearer. In the normal probability distribution, here the z value is plus 1.96 and here it is minus 1.96, and this area shaded is 0.025 of area and 0.025 total area will be 1 here, and this range is called as acceptance range. This is mu equal to mu naught. And here we are considering the two-tailed test. When I talk about two-tailed test, there are two-tailed or one-tailed tests, and their significance usually in the context of hypothesis. And these two-tailed test is appropriate so here I can write acceptance range, this is rejection range, both sides. This is total 95% of acceptance level in case of two tests. Then the two-tailed test is appropriate when null hypothesis is a specified value and the alternate hypothesis H1, HA is a value not equal to the specified, maybe more or maybe less, and therefore the two-tailed test is appropriate for the statistical test, and usually it is all these follow the normal distribution table and given by a statistics, whether it is sufficiently small or sufficiently large. The test is named as a tail of data because this tail of data is far left with respect to the bell-shaped normal distribution curve. That is why we call it as tail, two-tailed test. However, the terminology to the extending to the test is because of the distribution of the normal, and symbolically it can be written as H naught is to mu is equal to mu H naught, and HA is to mu is not equal to mu H naught, which may mean mu is greater than mu H naught or mu is less than mu H naught. So there are two rejection regions, one on each side of the tail as shown here. Mathematically also it can be written, and The level of significance here is 5% and the region of acceptance is 0.95. The total this will be 0.95 approximately. So 95% of the region area is covered under acceptance region. Thus, this is what we call it as two-tailed test. Okay. Hence, if a sample mean does not deviate significantly from the mu, then in that case we can accept the null hypothesis. Whereas here, this is the range where we reject the null hypothesis. The one-tailed test will be something like this. Mu equal to mu naught. This is the mean value, and this region, only this part of the region on one side is considered. And this complete is an acceptance region. And this is rejection. Any value or any variable beyond this is accepted. Here it may be rejected. Okay. And this population mean here is either lower or higher with respect to the hypothesized value. And in the one-tailed test, the null value is null hypothesis is rejected. So this can be considered as z equal to minus 1.645. Okay. And then this is, if we consider 0.05 of the area under a normal curve. So this is 0.45 and the 0.45 and above. And here the null hypothesis is rejected only for the test falling on one specified tail. Thus it becomes one-tailed test. And for our instance here, it is always H1 or HA is always greater than the, here we can write it as HA is to mu which is less than mu H naught, or it is equal to mu H naught. Hence, if we are interested to know the right tail test, then the rejection will be on the right side of the curve than the left side of the tail. So it depends on how we are supposed to determine. So this is always greater than less than mu H naught. Okay. Then if we use two-tail test or one-tail test for a given problem, it depends on the nature of problem and the null hypothesis H naught and the alternate hypothesis. And if the alternate hypothesis has two alternatives, then a two-tail test could be appropriate. And it should be remembered that accepting H naught on the basis of sample does not constitute to the proof. Thus, it only means that there is no statistical evidence beyond this. That is why it is rejected, to assert that H naught is true. So this is how we understand with respect to the data. It can be rejection rate, it can be flaws, it can be any other type of data that can be put into the one-tailed or two-tailed test. So this will help us in understanding the hypothesis and testing of the, these are the basic concepts for testing of the hypothesis. Then we will be going to the next, how to proceed with the testing of hypothesis. I will just read today the various steps, and then in the next class we will be dealing in detail. Testing of hypothesis. When I talk about various steps involved in testing of hypothesis, then it can be listed like this. It may include formal statement of the null hypothesis and alternate hypothesis need to be. So I'll just highlight the points today. formal statement, that is formulation of the statement of the hypothesis needs to be done. Then select the significance value or significance level. Generally in practice we say that 1% is always defective, hence it is put into the rejection rate, or 5% is put into the rejection rate. This has to be adopted well in advance for entire population. Okay, so selection of significance level. Then determination of appropriate sampling distribution. Once this is done, then go for selection of a random sample, compute the sample characteristics, and thus determine the region for rejecting the null hypothesis, that is H0. So in the next case, selection of a random sample and compute the null hypothesis or determine the critical region. Once we understand determining the critical region, then go for rejecting the null hypothesis here, and then compare the probability. If the type of probability is calculated which is less than the alpha value or alpha by 2, then in case of tail test, rejection of null hypothesis. So all these conditions and statistical data with various tables are available, and various criteria for rejection and formulation for rejection needs to also be mentioned here. Thus for test of significance or for testing of hypothesis with respect to test of significance, there are various tests classified: parametric test and non-parametric test. Under parametric test we have important parametric tests. We have Z test, C test, chi-square test already we discussed, and F test. Then under non-parametric test, there are various other aspects. I'll just read it out to you. And the parametric test, we assume that as we consider it for two-tailed and single-tailed, that is one-tailed test, or we consider that all the data is normally distributed. Okay. So we will come back to non-parametric test later on. There are various parametric or standard tests of hypothesis that one can consider, because there may be certain assumptions and there will be large population parameters also can be considered, and thus the major assumption is distribution of these data in the normal distribution characteristics. So I will stop here today. We will go with the procedure for testing of hypothesis and what are the limitations of the hypothesis, and take one or two examples on each of these test details. The flow diagram for testing hypothesis as well will be considered. Here very interesting problems are there with respect to the different parametric tests. Okay, and when we come back to non-parametric test, I'll just read it if it is available here. Under non-parametric test, there are sign tests and Fisher-Irwin test, or it can be Max-Lemmer test, or it is Wilcoxon matched pair test. All these are non-parametric tests. So we will not be going into the details of testing of hypothesis 2, where it is non-parametric and it is distribution p-test. We are only considering where the test where it follows a normal distribution pattern, and then understanding the null hypothesis or alternate hypothesis into it. So I'll be closing it here today.